Hi, I'm Derek Eckhart. For my semester project, I launched a blog called VizFix, which is dedicated to critiquing and rehabilitating troubled data visualizations. This is my final presentation. Troubled visualizations are everywhere. I'm a visual learner, so I wanted to figure out where these visualizations went wrong and see if I can improve them and sharpen my skills at the same time. And I'm not the only one fascinated by this. There's even a site simply called VizWTF. When it comes to data viz, simplicity is king. In Edward Tufte's The Visual Display of Quantitative Information, he really shows that you can take a simple design like the box plot and simplify it even more. In a modern example, as part of Makeover Monday, Ava Murray's Try My Data and Andy Crable's VizWiz, they take on a troubled visualization, identify what they like and what they don't, and then they make a better version. Here's Murray's, and here's Crable's. Let's see how my deep dive case studies turned out. First, I found this map showing the rate of vegetarianism in India. Green represents the percentage of vegetarianism, and the red is for the meat eaters. The more I read it, though, the less I understood. This data map uses overlapping circles to indicate the percentage, which is great for large percentages. When it's near 50%, the minority circle dominates, which is no good. These two are basically the same value, but look completely different. And let's not even talk about the inconsistent labeling. First, I tried a better data map, where circle opacity indicated percentage of vegetarianism, but you can't see the circles in the low percentage states. Next, I sketched the circles with a gradient, and that was better. I decided to try something different, because maps suffer an area equals population bias. I went simpler, and actually went with two scatter plots. The first one shows the percentage of vegetarianism as a function of north latitude with a clear trend up, and the second one shows the percentage of vegetarian as a function of east longitude with a clear trend down. My lessons learned from the first case: keep it simple and let the data do the talking. I like my scatter plots, but it needs a wow factor. Those are graphics only a mother could love. The next case study was on the Bitcoin economy relative to the world's money. Look at this thing. There's a lot going on here. They're really big pink spheres. I'm not really sure why we picked all of those indicators. And there's Bitcoin on the right instead of the left. Most of all, I couldn't figure out what the circle scale was. Maybe it's logarithmic or spherical volume. Nothing was noted. Also, I didn't like that each of these little images all needed additional explanation. If it needs explanation, then we don't need it on the graphic. Just for fun on the visualization, I limited myself to Excel because with 17 data points, any tool should do it. No, this was ugly, ugly, ugly. The radar chart isn't bad, but it's still more complicated than it needs to be. Ultimately, I went with the classic bar chart with a logarithmic scale. I also added some additional data points on the left, such as Michael Jordan's net worth and Iceland GDP, to give some more context for Bitcoin's actual value. My lessons learned on the Bitcoin economy case: trade-offs happen. I went with the log scale because it's technically correct, but not necessarily the most intuitive. And labels matter. You need to be able to understand the data, and I'm not positive I came up with the best solution. Here's a story about Pablo Picasso. He's at a bar and a man asks him for a drawing. Picasso sketches an elegant bird on a napkin in a minute. He hands it to the now ecstatic man and says, "That'll be 1,000 francs. But it only took you a moment to do that." The man says, "No, it took me a lifetime to be able to do that." Making those box plot simplification like Tufte or Picasso's art, those all came with years of experience. If we want to strive to improve our own visualizations, we need to keep making visualizations. That's a very key point here. Our goal in data visualizations is to be understood. As Professor Ahn pointed out to me, these little icons make the graphic more interesting. If it's interesting, people will read it and then they'll understand. And that's our actual goal. In order to make it interesting, are we designing for tiny niche audiences that will read it no matter what we put on the paper? Or are we visualizing for mass media where we need to focus on being accurate and interesting? If it's not interesting, people won't read it. Should I keep the icons or just text labels? Should I use a map or use a scatter plot? Knowing the audience matters because design is relative and there are trade-offs that have to be made in every single design. Folding in those lessons learned, on my next case study, I attempted to make sense of this data visualization about how baby boomers are perceived according to themselves and by HR professionals. While the overall design is actually pretty good, the center part just doesn't make any sense. More specifically, the coloring and the percents just don't make sense. Look here on the left. 40% takes up a full head, while on the right it's 55% is half a head. Or how about the fact that 17% has more shading than 44%? So first thing I did was I played around with data, and I made this actually quite elegant bar chart that actually does a good job of highlighting the differences. But one of the things we learned was we've got to make it interesting, and bar charts are not that interesting. Ultimately, I came up with this waffle chart. It's clear, it retains all of the information from the data set, and it's still pretty easy to see the differences between boomers and HR professionals. I really impressed myself here. My two main immediate takeaways from this case study: percentages matter. You just can't have more than 100% on a pie chart. And two, it really is worth the extra effort to make something look interesting. Next up, I worked on this data map of solar eclipses from 2001 to 2020. I was inspired by the work of Murray and Crable to see if I could create something that complemented their work. The original graphic isn't that bad. The eclipse paths are well done. We don't mind the Mercator because most of the data is near the equator. But ultimately, all these little labels just made it really overwhelming to look at. When I looked through the data set, I was intrigued by eclipse magnitude. I got this cool scatter plot of eclipse duration against the magnitude. Just for fun, here it is on log scale. Look, it can fly. With some SVG fun, I got this. It explains the two main types of eclipses, annular and in total. The title is playful, alluding to the wing shape of the scatter plot and the halo of the annular eclipse. And then lastly, I used charcoal instead of black to add depth. My lessons learned so far: I didn't have a lot of text, but the text I had was effective at adding a lot of value. And I went beyond the limit of what I thought I could do with SVG. You really do need to challenge yourself. For my last case study, I took on this infographic of the US tourism industry. Aside from the redundant text on the outside of the graphic, perhaps this was not the time to make a visualization that looked like Candyland. Scaling is the biggest issue. It's confusing. The numbers don't correspond to the number of visitors. By the way, did you see that they used the wrong flag for Japan? That's their maritime self-defense flag, not their national flag. So when I started looking at the data, I saw something that concerned me, that we would have to account for this big difference between Canada and everyone else. Also, while this graph is correct, we can't use a bar chart because it's not interesting. First, I failed at making an interesting waffle chart. Then I realized that creating something awesome like this Avengers network chart was well beyond my skill set. So I went back to pen and paper for a concept, and that led to it's a network graph, where the countries of origin are arranged near their geographical location, so it's familiar while still a bit abstract. To show the scale, I marked where the most came from and the least came from, giving context to the line thickness. My lessons learned on this one: despite technology, pen and paper is still the best way to sketch out ideas, and I had to keep working to find that solution that I was really happy with. And I think there's even a better solution out there that I'll have to find one day. In the course of these case studies, I've used HTML, CSS, Excel, R, Python, D3, JavaScript, Gephi, Paint, and Photoshop. I also could have used Tableau or Bootstrap. There is no one perfect way to visualize data. I'm showing you this one from the baby boomers case again because this was the first time I used everything I knew to make a clean, professional looking graphic that was beyond my skill set at the time. You can surprise yourself with a good challenge. And nothing is perfect. As much as I love this eclipse graphic, there's more that I can improve. For example, these eclipses, they kind of look like eyes to me, and I think it's winking at me. It's a little bit distracting. Am I the only one who sees that? So what comes next? For me, well, I need to keep on improving. I want to be able to make something like this Avengers network. Better skills mean better visualizations. Keep learning. And secondly, I need to keep practicing. Once I learn to make that awesome Avengers graphic, I have to keep practicing those skills. Otherwise, they'll decay. Thank you very much for your time. I've had a great time this semester.